I am Dr. K.V. Girija, Associate Professor, Department of Science and Humanities. Now I am going to present about Gram-Schmidt orthogonalization in vector spaces. This is the method which is used to construct an orthogonal basis. This is the process of constructing an orthogonal basis of V from an ordinary basis for V is known as Gram-Schmidt orthogonalization process. Now, let V be a finite dimensional inner product space. Then V being a finite dimensional product space, vector space has a basis V which is equal to V1, V2, etc. Vn. This basis can be used to construct an orthogonal basis of inner product space V. The process of constructing an orthogonal basis of V from an ordinary basis for V is known as Gram-Schmidt orthogonalization process. Now let us see an example problem. Let S be a subspace of the inner product space R power 4 spanned by the vectors V1 equal to 1, 1, 1, 1, V2 equal to, it is in R power 4, so we will get 4 numbers, and 1, 2, 4, 5, V3 is 1, minus 3, minus 4 and 2. Now apply Gram-Schmidt orthogonalization process to find the orthogonal basis and an orthonormal basis of S. Here we observe that the vectors V1, V2, V3 form a linearly independent set. Is it not? Now V1, V2, V3 is a basis for S. To orthogonalize the basis, let us define W1 is equal to V1, W2 equal to V2 minus inner product V2 W1 by W1 W1 into W1, which is V2 minus, find out V2 W1. Here we have got V1 equal to W1. So for W1, we have to take the values of V1, 1, 1, 1, 1 into V2. V2 values given already. So when you find out the inner product space, we will get the value as 12 divided by W1 value is also 1, 1, 1, 1 into 1, 1, 1, 1. We will get 4 into V1. Then V2 minus 3V1, which will then substitute the corresponding values of V1 and V2 in this. We will get the value minus 2, minus 1, 1 and 2. Now next to find out W3. W3 equal to V3 minus V3 inner product V3 W1 by W1 W1 into W1 minus inner product V3 W2 by W2 W2 into W2. In the same way, you substitute V3 minus, then V3 inner product of V3 W1 find out, and W1 W1 multiply, then W1 equal to V1. In the same way, let us find out 7 by 10 values for inner product of V3 W2 by W2 W2 into W2. Now all the values we got, and W2 value also we got, substitute in the corresponding places, we will get it as 8 by 5 minus 17 by 10 minus 13 by 10, 7 by 5. Thus W1, W2, W3 is an orthogonal basis of S. Next we have to find out an orthonormal basis. The formula is Ui equal to Wi by norm Wi. Now we know how to find out norm W1 square, which is nothing but inner product of W1 W1, which is 4, and norm W2 square, which is inner product of W2 W2, which is 10, and inner product of normed W3 square is inner product of W3 W3, value is 910 by 100. Then orthonormal basis is Ui equal to Wi by norm Wi. Then substitute all the Wi values, U1, U2, U3, everything we can find out using the above values, this will form an orthonormal basis of S. In the same way, let us do this problem. Let S be the subspace of R power 4 spanned by the vectors V1 equal to 1, 1, 1, 1, V2 value given and V3 is given. Apply Grant-Smith orthogonalization. Let us find to find an orthogonal basis of S and also the projection of V onto S. Now, in the same way, let us write W1 is equal to V1 and the W2 formula you apply. Let us get, like the previous problem, we will get 0 minus 2, 1, 1 and W3 is, substitute the values, we will get V3 plus W1 plus 11 by 6 W2. We will get in the corresponding places, let us substitute all the values. We will get 2 minus 2 by 3 minus 1 by 6 minus 7 by 6. Now, let us find out a new W3 value, which is W3 dash. You multiply by 6 to avoid that denominator. So when you multiply by 6, we will get 12 minus 4, minus 1 and minus 7. Clearly, W1, W3, W2, W3 form an orthogonal basis of S. Now let us find out projection of V on S. To find out that, let us use inner product of V1, W1 by inner product W1, W1, like that previous problem, like the previous formula, we will get into W1 minus inner product V1, W2 by W2, W2 into W2 plus V1, W3 dash by W3 dash W. Because of finding this W3 dash, it won't affect any of the values. Just to avoid our denominator, we are changing that W3 into W3 dash by making it as 6W3. Then into W3 dash. Now substitute in all the, find out all the inner product values. Then substitute in all these, we will get projection of V on S is minus 1 by 5, 12 by 5, 3 by 5 and 6 by 5. This is the way to find out. We use Grant-Smith orthogonalization in the problem. The only thing, we have to keep this formula without any confusion in mind. This is the Grant-Smith orthogonalization process. Thank you.